For problem 54 and trying to figure out which one of these graphs is f, which is f prime, and which is f double prime, the first thing we need to make sure we understand is that f prime just shows the slopes of f. So then if we look at this horizontal line first, if we see a graph of the slopes everywhere along the way, which everywhere on this graph the slopes are 0. So if we see this graph's derivative, then we would see a y equals 0 for the slopes of all the tangent lines to this graph, and we don't see that, so there's no way that this graph could be f. Well, let's look at this next diagonal line and let's see if we can find its derivative here. So this diagonal line has a constant slope, and the slope is positive, and so therefore this could be f, and then this graph right here, this horizontal line, would show a constant positive slope, so this could be f prime. Well, let's see then that it's impossible though for this to be f and this to be f prime, because if this was f prime, then this would have to be f double prime, and this we already talked about that. This graph right here, this horizontal line, doesn't have a derivative graph, so this has to be f double prime. So if this has to be f double prime, then this one has to be f prime, can't be f double prime, and then that would leave f double prime for this parabola. That's one way to look at it. Oops, sorry, I messed up. That should be f. So we took care of this diagonal line being f prime, the horizontal line being f double prime, and therefore it leaves f for the parabola. And then if you think about it, all three of these are polynomial functions, and so if f is a polynomial function, you would say, oh, that's a second degree polynomial. We're not sure, we don't really care what the constant is, but it's some polynomial that has a degree 2. And then when we take a derivative of a quadratic function, we get a linear function, which would be this one here. And then when we take the derivative of a linear function, we just get a constant. And so that would be another way to look at the three graphs and to figure out which one's f, which one's f prime, and which one's f double prime. And but they're not always going to be polynomials, so you can't rely on that. Let's start over. Let's look actually at the parabola and see if we can figure out, well, how would we find the graph of the derivative of this parabola? That's really the thing that you need to make sure you know how to do. If we look at a graph, we want to find where the f prime is 0. In other words, where we have a horizontal tangent line, and we have a horizontal tangent line when x is equal to 0. Therefore, the graph of the parabola's derivative would have to go through x equals 0, because slope of f prime is 0. If this is f, the slope is 0 here, and so the value of the derivative of this parabola graph would have to be equal to 0 there. And then to the right, anywhere along the way, we're going to have a positive slope of a tangent line. Anywhere to the right of 0, the slope is positive, and therefore the graph of the derivative of this parabola would have to be positive. That's what we show here. And then likewise, anywhere to the left of 0, the derivative graph would have to have a negative value, and that's what we have here. So certainly the diagonal line is the derivative graph of if the parabola is well, it's the graph of the derivative of the parabola, and then we already talked about that the horizontal line is the graph of the derivative of the diagonal line. So again, that's just another way to look at it. You can look at, you could pick any one and just make sure you're graphing the slopes of the tangent lines, showing the y values for the slopes of the tangent lines when you're drawing the graph of the derivative. Easier even just to start with a graph and see if you can figure out, well, let's start with a parabola. Let's draw the graph of the derivative. Well, the slope of the tangent line is 0 there, positive anywhere there, negative anywhere to the left, and then you get a diagonal line. And you get only this diagonal line that would show, oh, it would look something like that. So that's it.